Welcome back to Robominions.in AI interview preparation app. The topic of this video is recursively inserting in binary search tree. So let's look into the recursive insertion. So this is the code. Before tracing the code, I request you to watch this video on a laptop or at least make a full screen on your phone. If the code is not visible properly, strongly suggest you to watch it on a laptop because each individual line of the code is traced and each individual line of the code is explained. So I request you to watch it on a laptop, and after watching the video, for revision purpose, you have to download Robominions.in AI interview preparation app. There are hundreds and hundreds of concepts in computer science, and it's very hard for any student to map all the concepts in their brain. So this app will give that mapping and a clear structure for revision. So whenever you want to revise before going to an interview or before going for an exam, you can quickly revise all the concepts by just clicking back and next button. You control the code execution and see what exactly is happening inside the code. Watch the video tutorial. By just clicking on video tutorial, you get the video tutorial. Watch the video tutorial and get the explanation. And the next time when you're revising, you can just control the code using back and next button. To download the app, visit the website robominions.in. Click on the download latest version of the app. The app is updated every 3 months with new topics and lot of bug fixes. Click on download. If you have a Windows OS, click on download for Windows OS. So let's start tracing the code here. Okay, we have recursive insert in binary search tree. Yeah, and please follow this arrow. This arrow will go to the execution points of the code. So right now we have hash include stdi.h. Then we have hash include stdlib.h. Then we have type def struct node. In the going back step, in this structure we have left child, data and right child pointer. Struct node type def is a renaming. It's a keyword which we use for renaming a lengthy name of a data type. So struct node is renamed to just node. So we use this node everywhere. So we are creating node a root pointer of type node and root equal to null. Then we have r recursive, that is r underscore insert to bst function declaration, which takes node pointer ptr and key. Now we call int main. We have int main. Now root equal to r insert to bst root comma 11. So we call this function. So right now the pointer ptr is pointing to is equal to root address. So whatever address the root had. Right now root is null. So ptr is also null. Key is 11. So we have passed 11. So we want to insert that data. So new node equal to, so we are creating a new pointer here. New node equal to null. ptr equal to null. Yes, the if condition is true. Then we have new node equal to a new node memory is allocated with the size of node and typecasting done with a node pointer. So we go to the structure. This node is created. It has a garbage value with a address hash 100. And then we have new node data equal to key. Key right now is 11. So 11 is added to this node. Then left child is null. So we declare left child equal to null. Then we have right child equal to null has been added. Then we return this new node back to the main function. So new node has been returned. So root equal to is pointing to this new node created. So right now root is pointing to this node. Now again we call the second recursive function r underscore insert to bst. This time we are passing the root comma 9. So 9 data has to be inserted to this binary search tree. So node is r insert to bst is being called. New node equal to null. If ptr equal to null. So this ptr has received root. Root is, that is hash 100 address. So hash 100 address is not equal to null. So this node is not equal to null. So it doesn't go inside the if condition, it goes to the other if. So the after that we have this if. This says whether checks whether key less than ptr data. So right now ptr is pointing to this node, key is 9, ptr data is 11, 9 less than 11 is true, so goes inside the if condition. Here ptr left child, so ptr left child equal to r. So we have a recursive call of r insert to bst, and we are passing ptr left child comma key. So the key here is whatever we have received, the key is 9, 9 is being sent, then ptr left child is null, null is being passed. So when I call this recursive insert, again a recursively called function, again a new node pointer is created. Now this time ptr equal to null, because ptr left child, you can see here left child is null. So null, so now we create a new node here. A new node is created, a memory is allocated, malloc. Yeah, new node is allocated with memory. It has a garbage data value with address hash 200. Then new node data is equal to key. Key was passed is 9. 9 has been assigned. New node left child equal to null. New node right child equal to null. Then this new node is returned to ptr left child. So ptr left child will get hash 200. When I click next, you see the link is established. The node has been successfully inserted, and to the left side, left child is updated with hash 200. Then we return this ptr, which was pointing to this, to the root again, because the ptr was pointing to this. So root is again pointing to the main node. Now we insert 22. So recursive insert is called again. We have a new node equal to null, and ptr is pointing to this node again. So ptr equal to null is false. It comes to the if condition here. Now the data key is 22. 22 is less than 11, it is false. 22 is greater than 11 is true. So the idea of a binary search tree is you add the data less than the parent data to left side, data more than the parent is added to the right side. So 22 is more than 11. So now we have to add it to right side. So we are going to access the ptr is pointing to this node. So ptr will access the right child. So you see ptr is accessing the right child, to which we call the insert to bst function again. To insert the new node, we pass ptr right child address. We pass that address. When you see ptr right child is null, null has been passed, and the key passed is 22. So it goes to new node equal to null. Ptr equal to null is true, because the right child is null. You can see it goes inside the if condition. A new node has been allocated with the memory, say garbage value and hash 300. New node data equal to 22. So 22 has been added. New node left child equal to null. New node right child equal to null. Return the new node. Hash 300 will be returned to this node. So the link will be established. When I click next, you see ptr right child hash 300 has been assigned. So the link is established. Then we return the right now the ptr is this. So we return the ptr. Ptr is returned to root. So root equal to ptr. So we have successfully and recursively inserted node to binary search tree. So just a sample small tree which we have used to insert. Okay. Now we come out of the main. So the time complexity is order of log n for recursive insertion of binary search tree, or any insertion in a binary search tree. I hope you like this video, and if you want to access this code and want to add more recursive insert, you can click on the code button in the Robominions.in AI interview preparation app. And don't forget, you can always use back and next button to control the code, and you can visualize yourself for revision purpose, how the address is getting changed, how the link is established. Okay. And always the video tutorial is available. Just click the video tutorial and you can watch the video if you forget, and then revise and then come back to the app. See you guys in the next video. Thank you. Signing up, Dhananjai Sharma,
founder of Robominions.in. Don't forget to subscribe to the YouTube channel, share with your friends and family. Visit Robominions.in website, crack your toughest coding questions and tech interviews by downloading latest version of the app, and make your coding easy. Thank you for watching this video. Bye.